Good morning, good afternoon, everyone. Welcome to the Tenerife summer sessions. My name is Ranjeet Sharma, and today we are going to talk about something that is quietly shaping every major decision in the modern world: artificial intelligence. And more specifically, we are going to talk about how AI can get things very, very wrong. The session is titled Fair AI in Practice, Detecting and Reducing Algorithmic Bias. And over the next 25 to 30 minutes, I want to take you on a journey from understanding what bias is to actually knowing what to do about it. Guerendinga Tech has built an incredible community of technologists and thinkers, and this conversation is one every one of us in this room needs to be part of. Before we dive in, a quick word about me. I am Ranjeet Sharma, an analyst at Tata Consultancy Services, one of the world's largest technology companies. I work at the intersection of data, technology, and business, and the question of fairness in AI is something I encounter in real projects with real consequences. I am not here as a researcher presenting theory. I am here as a practitioner, someone who has seen firsthand how the choices we make when building AI system end up affecting real people. If you would like to connect after the session, I would love that. You can find me on LinkedIn. Details are on the slide. Let's talk about fair AI in practice. We have been told for years that AI is objective, that unlike humans, machines do not have prejudices. They don't have bad days. They don't have unconscious biases. And yet, time and again, we see AI system producing outcomes that are deeply unfair. Hiring algorithms that disadvantage women, healthcare models that work well for one ethnic group but fail another, credit systems that deny loans to people in certain zip codes. So what's going wrong? The answer is that AI systems learn from data, and the data is created by humans in a world that has never been perfectly fair. When we feed bias history into an AI, it learns that bias and then scales it across millions of decisions. Today we are asking a critical question: how do we build AI systems that are not just accurate but actually fair? So let's think about this for a moment. I am pretty sure like some of us have applied for a job in last few years. There's a good chance that an AI system reviewed your CV before a human ever did. It decided in milliseconds whether you were worth a recruiter's time. Now think about accessing a bank loan, or being flagged by a law enforcement system, or getting a medical diagnosis supported by AI-driven analysis. AI is now embedded in the most consequential decisions of people's lives. Who gets hired, who gets credit, who gets treated, who gets flagged. So what that kind of reach comes an undeniable obligation. These systems do not just reflect the world, they shape it. And if those systems are biased, then the inequalities they encode get replicated faster at scale and with the false authority of the computers said so. This is why we are here today. So let's talk about what is algorithm bias. So let's define our terms. What exactly is algorithm bias? Algorithm bias refers to systematic, repeatable errors in an AI system that create unfair outcomes for specific individuals or demographic groups. The key word here is a systematic. We are not talking about one-off mistakes. We are talking about errors that happen again and again in the same direction, affecting the same people. And here's the thing that surprises many people. These biases are usually not intentional. Nobody sits down to write biased code. The bias creeps in through the data we use, the assumption we make, the feature we choose, and the way we define success for our models. Think about it in this way. If you train an AI to predict who will be a good employee, and your historical data shows that most successful employees were men in their 30s from certain universities, the AI will learn to prefer those profiles, not because it's sexiest, but because the data told it that's what success look like. So now you might say, Ranjeet, that sounds like an ethics problem, not a technology problem. Why should we as a technologist care, right? And the answer is because it affects everything we care about as a professionals and as a builders. First, decision quality. Fair AI makes better decisions when a model evaluates people on relevant information rather than demographic proxies. It actually performs better for the business. Second, user trust. People are willing to engage with AI system only when they trust them. Transparent, explainable decisions build that trust. Biased, opaque ones destroy it. Third, regulatory readiness. The EU AI Act and a growing body of global regulations are making fairness a legal requirement. Organizations that haven't built fairness into their system will face significant compliance risk. And the fourth one, business outcomes. Fairness isn't just a good ethics, it's a good business. Fair system improve customer satisfaction, brand reputation, and long-term sustainability. So let's make this concrete with 3 examples from the real world. Hiring. In 2018, Amazon had to shut down an AI recruiting tool because it consistently ranked female candidates lower than the male candidates for technical roles. The system had been trained on CVs submitted over a decade, and because the tech industry has historically been male dominated, the model learned to penalize signals associated with the woman, like the word women's in phrases such as women's chess club. Amazon caught it and shut it down, but how many organizations do not catch it? Healthcare researcher published in Science Journal found that a widely used healthcare algorithm in the US was racially biased. It consistently underestimated the health need of black patients, meaning they received less care than equally sick white patients. The algorithm had used health spending as a proxy for health needs, not accounting for the fact that system barriers meant black patients spent less on healthcare, not because they were healthier, but because they had less access. Let's talk about lending. Credit scoring models trained on historical data can reflect decades of discriminatory lending practices. A postal code that correlates with race or socioeconomic status can become a proxy variable that disadvantages entire communities. So these are not hypothetical edge cases. These are systems that are in production today affecting millions of people. So some of the common sources of bias. So where does the bias come from? Let's break down the most common sources. The first one is historical data bias. Our training data reflects the world as it was, not as it should be. If past decisions were discriminatory, AI will learn to replicate that discrimination at scale. The data is a mirror of history. The history is often unjust. Sampling bias. If your training data underrepresents certain population, rural communities, older adults, people from global south, our model will simply not know how to handle them well. It will generalize poorly, and the groups that are already marginalized get the worst performance. Third one is measurement bias. This is a subtle one. It's about inconsistency in how data is collected before it even reaches us. Different hospitals using different diagnostic criteria. Surveys that are worded in a ways that skew responses. Census calibrated for one environment deployed in another. The error is baked in before training begins. We have 3 more sources to cover, and these are the sneaky ones that even experienced data scientists missed. Feature selection bias. When we build a model, we choose which variable to include, but some variables that look neutral are actually proxies for protected characteristics. Zip code correlates with race and income. Educational institution correlates with the class and geography. Employment history correlates with the gender, specifically for people who took career breaks for caregiving. Even if we remove the explicitly sensitive attributes like race, gender, religion, the model can reconstruct them from these proxies. Label bias. In supervised learning, we train models on labels. But where do those labels come from? Often from human judgments, performance reviews, credit risk score, recidivism, risk assessment. If the people who made those judgments were biased, even subtly, even unintentionally, then those biases become embedded in the model as ground truth. Algorithm design bias. When we optimize a model for overall accuracy across the whole population, we are often implicitly optimizing for the majority. Minority population can end up with a systematically worse prediction quality, not because we try to harm them, but because we didn't measure separately for them. Let me now give you a clean taxonomy. When we talk about bias in AI, we are actually talking about 5 distinct types, and they occur at different stages of the pipeline. The type 1, representation bias. Some population appears far less in training data than they do in reality. If your facial recognition model was trained mostly on lighter skin tones, it will be less accurate for people with a darker skin tones. This has been demonstrated empirically repeatedly. The type 2, historical bias. Even perfectly collected representative data can be embedded societal inequalities because the societies we are collecting data from are themselves unequal. This is perhaps the most difficult bias to address because removing it would mean rewriting history. Third one, type 3, aggregation bias. This happens when we build one model for a population that is actually heterogeneous. For example, glucose level that signal diabetes behave differently across different ethnic groups. A model built on aggregated data may work well for the average, but performly poor for specific groups with a different underlying biological patterns. Type 4, evaluation bias. This is quality assurance failure. If our test set doesn't reflect real world diversity, we will think our model is performing well when it is not. We ship confident model that quietly fail in production for certain users. Type 5, deployment bias. This is when a model is used in a context it was never designed for. A model built for adults being applied to children. A mental health screening tool built for clinical environments deployed on a general consumer app. My next slide talks about bias across industries. We have seen the theory. Now let's look at how this plays out across 3 of the most consequential sectors: hiring and recruitment. Bias can enter through historical preferences, the kind of universities that were prioritized, the geographical reason considered, the soft signals that were valued. Fair system focus only on job relevant companies, no more, no less. So the ask is, can this person do this job? Not. Do they look like someone who has done this job before? The financial services. Credit scoring is particularly fraught. Applicants within thin credit files, often young people, immigrants, or those who relied on cash economics, can be systematically disadvantaged. The history of lending in many countries carries deep inequalities, and models trained on that history replicate them. Healthcare. In healthcare, the stakes are literally life and death. Diagnostic AI must be validated across age groups, ethnic groups, sexes, and socio-economic backgrounds. A model that performs at 95% accuracy on one group but 70% on another is not a 95% accurate model. It is just a 70% accurate model for the people who need it most. Let's look at two more sectors that are particularly in the spotlight right now. Facial recognition. MIT researcher Joy Buolomwini demonstrated that commercial facial recognition system had error rates up to 35% for dark-skinned women versus less than 1% for light-skinned men. The reason? The training dataset were overwhelmingly composed of lighter-skinned male faces. When you test a system only against the data it was trained on, you won't see these disparities until the system is deployed in the real world and the harm becomes visible. The lesson here is clear. Balanced dataset and continuous, disaggregated testing across age, gender, and skin tone are not optional. They are the minimum bar. Education. AI-driven personalized learning tools are increasingly being deployed in schools. The promise is exciting. Customized learning journeys for every student, but the risk is real. If these systems are trained on data from well-resourced school with stable internet across and English as the primary language, they will advantage students who already have advantages. The AI could entrench the very achievement gaps we are trying to close. We need AI in education that is designed to lift all students, not to accelerate only those who are already ahead. So, now we have spent a lot of time on the problem. Let's start talking about the solution. And I want to begin with something important. Fixing bias is not just a technical problem. You cannot write an algorithm that eliminates bias. No amount of clever mathematics can substitute for the fundamentally human work of asking, is this fair? Who are we missing? Who might we be harming? Fairness must be embedded throughout the entire AI life cycle. From the moment we define the problem, through how we collect and prepare data, how we build and evaluate models, how we deploy and monitor them. Every stage introduces risk. Every stage is an opportunity to do better. And this work demands diverse teams because homogeneous teams have homogeneous blind spots. So it demands inclusive design practices and it demands a culture of accountability where fairness is not a box you tick at the end, right? But a value that is present from day one itself. So let's talk about the AI life cycle. Here is the life cycle and I want to look at it not as a technical pipeline but as a chain of ethical decision. So first define a problem, collect and prepare your data, develop your model and then evaluate your model. Each phase is a gate where bias can enter and each phase is an opportunity to stop it. The challenge is that organizations often only ask, is this fair? At the end, during evaluation, when the bias has already been baked into the data and the model for months, proactive beats retroactive. Addressing fairness at the problem definition stage costs almost nothing. Addressing it after deployment when harm has already occurred and regulatory penalties are looming cost you enormously. So let me walk you through each phase. Okay, so phase 1, define the problem. This is where fairness work should begin, not end. Before you write a single line of code, ask, who is this system for? Who could it harm? Have we included the voices of affected communities in defining the problem? What does success look like and for whom? A system designed to optimize hiring efficiency will behave very differently from a system designed to identify the most qualified candidates equitably across all backgrounds. The problem framing sets the direction of everything that follows. Phase 2, data collection. Collect data that is representative of the real world, not just the convenient world. Document your sources, map your demographic coverage, identify who is missing, and actively work to fill those gaps, whether through augmentation, reweighing, or targeted collection efforts. Phase 3 and 4, like prepare and develop. Data preparation. The choices made in this phase are invisible to end users but hugely consequential. Remove duplicate records that overrepresent certain groups. Handling missing values carefully. Don't impute in ways that assume a majority group norm. Review every feature and ask, is this variable a legitimate predictor or is it a demographic proxy? This is where you catch things like zip code, employment gap, or graduation year acting as a stand-in for race, gender, or class. Phase 4, model development. Resist the temptation to optimize for the single metric of overall accuracy. Compare multiple algorithms and see which forms most equitably across subgroups. Measure fairness metrics alongside accuracy metrics from the very beginning. Document your assumptions. What are you assuming about the population, about casualty, and conduct peer reviews. Fresh eyes catches things we normalize over time. Phase 5, model evaluation. So this is where most teams focus their fairness efforts, but it should be a checkpoint, not a starting point, right? The golden rule: never report only aggregated accuracy. Always measure performance disaggregated by demographics subgroup. Your model may be 94% accurate overall while being only 70% accurate for women over 50 from rural areas. You will never know unless you measure. Use dedicated fairness metrics, not just accuracy. Metrics like equalized odds, demographic party, and predictive party tell you very different things about how fair your model is and for whom. Validate on independent data sets, not just your training split. Use data from different time periods, different geographics. These catches evaluation bias. Review model explainability. Understand which features are driving predictions. If a feature you thought was like neutral turns out to be the most important predictor, that's a signal worth investigating. And critically, identify performance gap before deployment. It is infinitely easier to address bias in a test environment than in the production. Now the phase 6 comes for the deployment. This is where AI meets reality and where responsible practice matters most. Human oversight. For high stake decision, hiring, lending, healthcare, criminal justice, AI should be advisory, not final. A human must be in the loop with the authority and responsibility to override the system. The AI said so is not a acceptable explanation for a consequential decision about someone's life, right? So monitor outcomes from day 1, not month 3, not when something goes wrong. From day 1, set up dashboards that track prediction distribution by demographic group. If you see drift, investigate immediately. Transparency. People affected by AI decisions have a right to understand them. The EU AI Act increasingly mandate this. Build explainability into your system architecture, not as a retrofit. Feedback loops. Create structure mechanism for users, operators, and affected communities to flag problems. A user who notices a bias in your system is a gift. Treat that feedback as a bug report, not a complaint. The phase 7, continuous monitoring. And finally, because responsible AI is not a one-time activity, it is an ongoing commitment. The world changes, your data changes, your users change, and your model will drift. So the first part I will talk about here is data drift. The statistical properties of your input data will shift over time. If your model was trained during a pre-pandemic economy and deployed post-pandemic, it may be making prediction based on a world that no longer exists, right? So monitor your input distribution continuously. Population changes as your users base evolves, as you enter new markets, as demographic shift, new forms of bias can emerge for groups that were not well represented in your original training data. Monitor disaggregated metrics for emerging subgroups. Then comes model degradation. Prediction consistency can quietly, deteriorate before harm becomes visible. Set automated alerts. Define acceptable performance thresholds by subgroups and treat falling below them as an incident requiring response. Think of your deployed AI the way you think of a production system. You don't just deploy a server and walk away, right? You monitor it, you watch it, you patch it, you retire it when it's no longer fit for, purpose. So now the question comes, who is responsible for all of this? The answer is everyone, right? And that's not a cop out, it's the truth. So here I will talk about developers, organizations, regulators. So developers, we control data quality, algorithm designs, and the fairness matrices we choose to measure, right? So we make dozens of technology decisions every day that have ethical implications. Owing that responsibility is a part of being a professional. Organizations. Leadership sets the governance frameworks, the oversight structure, the culture of transparency. If an organization rewards speed to market over fairness, that's what it will get. Accountability starts at the top. Regulators, standards, guidelines, and compliances frameworks create the floor beneath which no organization can fall. The EU AI Act, emerging global frameworks. These are not threats to innovations. They are the rules of the road that make AI trustworthy for everyone. But none of these groups can do it alone. Fair AI requires cross-functional collaboration. Data scientists working alongside ethicists, legal teams, domain experts, and representative of the communities being affected. My next slide talks about some of the key principles of fair AI. Excuse me. So let me leave you with your principles you can take away from today and apply in your work immediately. Principle 1. Start with the data quality. Representative, well-documented data sets are the foundation of everything. Before you build anything, audit your data. Know what it contains, who it represents, and who it leaves out. Principle 2. Measure fairness explicitly. Make it first class metric alongside accuracy, precision, and recall. Break your evaluation down by demographic subgroup. If you don't measure it, you can't improve it. Principle 3. Maintain human oversight, specifically for high stake decisions. AI should augment human judgment, not replace it. Build in review mechanism, exception workflows, and clear accountability chains. Principle 4. Monitor continuously. Bias can emerge at any time, right? As your data changes, your users change, or the world changes. Set up monitoring before you go live. Treat fairness as an operational concern, not a one-time sign-off. So 4 principles, all actionable, all starting today. Now the question comes, fair AI is achievable? I want to end with something optimistic because I genuinely believe it. Fair AI is achievable. This is not a utopian aspiration. It's a practical, technical, and organizational challenge that we know how to address. The tool exists, the framework exists, the knowledge exists. What is required is the will to prioritize, the humility to recognize that our system might be wrong, the discipline to measure, iterate, and improve. Building trustworthy AI means ensuring technology benefits everyone, not just the majority, not just those who are already well served by the system of the world. By embedding fairness into every stage of the AI lifecycle, from data collection to continuous monitoring, we can build systems that are accurate, equitable, and worthy of public trust. That is the goal, and it starts with all of us in rooms like this one deciding that it matters, right? So, yep, thank you. This is all about my today's presentations. And before I open it for questions, let me leave you with this. Every AI system you build or use has embedded choices. Choices about what to optimize for, choices about what experience matters, choices about what counts as a success. The question is not whether AI will make decisions that affect people, it will. The question is whether we will be the people who made sure those decisions were made fairly, right? So I believe we can, and I believe rooms like this one with communities like Gorandinga Tag are where that change begins, right? I am Ranjeet Sharma. It's been an honor, and I'm happy to take any questions if you have. Or as I said earlier, you can always connect me over my LinkedIn profile, and the details are present in the slides. So once again, thank you everyone. Thank you for your time.